So in our next example, we have another opportunity to run through the process to identify just specifically vertical asymptotes. And so as we play through this problem, we have an interesting result this time. They're all interesting, but this is especially interesting, I suppose. Step 0, factoring the denominator. You divide out a 5 common factor, and the denominator is going to turn into x minus 4. And so I can quickly identify my point of discontinuity by setting the denominator equal to 0, and solving. And so I get x equals 4 is a point of discontinuity. Remember, disregard the 5. Really, you're dividing the 5 out, and it becomes 0. And so just the x minus 4 is anything. Please don't tell me the x equals 5 is a point of discontinuity. It is not. It's just a coefficient that needs to go divide from 0 and become 0. So point of discontinuity is 4, which means my domain is all real numbers, comma, x can't be 4. Now, what that means is that I have a candidate, a possibility for a vertical asymptote, but it might be a hole. So my job is to go ahead and follow through the process and focus on now the numerator. I got to factor the numerator, recognize that there is a common factor of 3x. So 3x can be factored out of the numerator. If I divide 3x squared by 3x, you'll produce an x. If you divide negative 12x by 3x, that'll produce a negative 4. So in rewriting this function, I will see I have 3x times x minus 4 over x minus 4. And then what happens is in the next step, I'm supposed to reduce the function. And when I reduce the function, the x minus 4 reduces out completely. Anything divided by itself is 1. So the most reduced form of this function is just the function 3x. The function 3x has no domain restrictions in it. We originally had a domain restriction of 4. Our reduced out factor, x minus 4, produces not a vertical asymptote, but a hole. So this x equals 4 is a hole. There are no domain restrictions in the graph of 3x. That's actually just a line, the graph of 3x, that goes through the origin like this with a slope of 3. I didn't really draw a rise of 3, run 1 very well, but that is a slope of 3x. I'm going to say it is, not to scale. But anyway, the x equals 4, what that does is it actually causes a hole. So over here at 4, you would find that there'd be a hole right there, not a vertical asymptote. This graph is essentially a line piecewise defined with a hole in it. And so no vertical asymptote is the result for this question. No vertical asymptotes.